Alright, so we're going to go ahead and dive right on into section 3 of chapter 1, and we're now going to talk about the different types of experiments and how those experiments can be designed. So when we're talking about experimental studies, it's going to consist of experimental units. And experimental units are just basically our individuals being studied. Now, if you remember, I believe it was from section 1, I talked about the term individuals. Individuals is used loosely because we think of individuals as people, but it actually can be animals, plants, or things. And in fact, when we're talking in statistics about individuals that are people, we're more than likely going to refer to them as subjects. Okay, and so if we use the word individuals, we're probably talking about animals, plants, or some other thing. And we also may use the word experimental unit. So kind of remember those three terms and how they are used interchangeably. Now, some vocabulary when we're talking about an experiment, these are probably our two most popular vocabulary terms that you need to make sure you understand, is your treatment and then your outcome response. The treatment is just the procedures applied to an experimental unit. There's always two or more treatments. It's basically the thing that you're putting on your group to test. So maybe I am trying to test out this new pain reliever and to see how effective it is to make individuals feel better. So maybe one group is going to get the old pain reliever and the other group will get the new treatment, which is my new pain reliever, and so that would be my treatment item. Now the outcome that I'm looking for, the response, that's what's being measured on each experimental unit. So on each group I've applied the old treatment and the new treatment, and my outcome that I'm looking for is their response rate to I guess being healed, or the pain reliever working effectively to make them feel better. Now, there's two types of main experiments that we'll look at. It's a randomized experiment versus an observational study. And we're going to talk about the pros and cons to each of them and just try to understand what it is that we need to know about these. So in a randomized experiment, it's basically a study where the investigator assigns treatments to the experimental units at random. It's exactly what it sounds like. Everything happens random. It's very similar to a simple random sample. You're trying to conduct this study. You're going to put treatments on group A and group B, and I randomly put people in group A and I randomly put people in group B. So I've created this example here. Ms. K wants to see if her stat students learn better with or without the use of technology. So a simple random sample of 20 students were taught using technology, and then another simple random sample of 20 students were taught without using technology. So I put these students into the groups, but I did it by simple random sample, so everybody was equally likely to be in the in either of the two groups. And so at the end of the course, the students were given a test to assess their knowledge after being taught with or without technology. And so that's an idea of a randomized experiment. The only thing that I controlled was placing the students within their respective groups. But then again, I only controlled that to a small degree because I did conduct a simple random sample to do so. Now, a double-blind randomized experiment, this is actually the best type of randomized experiment. Neither the investigator nor the subjects know who has been assigned to which treatment. And the reason why this is good is it avoids all biasness. So in that last example, instead of me placing students into the group that's going to learn with or without technology, some third party, some outside researcher comes in and places them in the group for me and does all the studying for me, and then after he has studied everything and looked at all the effects, then gives me the results to go ahead and to analyze, and that reduces any sense of biasness that I may accidentally include when analyzing that data. Now, here's some perks. Why randomize? Well, I've already said it reduces the biasness, but further, it creates two groups that are very similar. So we don't live in a perfect world. When you create different groups, there is no way that you're going to create exactly two groups that are similar in every single aspect and really be able to compare them without a shadow of a doubt. It's just not going to happen because we don't live in a perfect world. But if you conduct a randomized experiment, those differences between the two groups are going to be very small. And so when we see big differences, when we see something very, very different between the two, it's easy for us then to conclude, well, it's probably due to the treatment that one of the groups is getting. Now, another type of study that we have is an observational study. The assignment to treatment groups is not made by the investigator. So let's say that I want to find out if people are more likely to do more shopping at Target if they pick up a cart versus a basket. And so I decide to evaluate the first 50 people who walk in and get a basket, and then the first 50 people who pick up a cart. And I'm going to look at all of the items that they purchase and see who spent more money. Well, I didn't tell Susie May, who walked into Target, hey, Susie May, pick up a basket, or hey, pick up a cart. I just let her pick up whatever she picked up. She did her shopping, and then I just evaluated what she purchased. So I really didn't play a role. I just looked on from the outside, and that's kind of the whole idea of an observational study. Now, there's different types of observational studies. We can get more specific into those. We have cohort studies, or we have case control studies. And then within cohort studies, we have prospective, cross-sectional, and retrospective studies. Now, I'm going to allow you to dive more into the specifics of these different types of observational studies on your own. That's within your textbook. But briefly, I want to just describe what these are. When you talk about a cohort is just a group of subjects, and generally they have worked together. So, for example, when I went to college for undergrad, I was in a scholarship program with individuals that were admitted at the same time as me, and we were called a cohort. And so we continued on in our educational processes, generally for the most part at the same time, and then my whole cohort graduated at the end of 4 years. And when you do a cohort study, it helps you to determine whether various factors of interest are associated with an outcome or not. And when we refer to perspective, cross-sectional, and retrospective, we're focusing on the time and the way that we follow those subjects. So if we have a prospective cohort study, then we are following these subjects over a period of time. If we're dealing with cross-sectional, then we're only focused on one point in time. And if we're looking at retrospective, well, that's going back to something that has already occurred and studying something that happened before. If we're talking about a case control study, you basically get two different samples, and then you're going to look back in time to determine whether a particular factor of interest differs between the two groups. So very similar to a cohort study in a way. So definitely want you to dive into that a little more on your own, and you can check that out within your textbook. But those are our main different designs of experiments. Definitely want to continue having that idea that conducting a simple random sample is always the best way to go. And if you are going to conduct an actual experiment, it does seem to have more perks when we create that randomized experiment. So some downfalls to an observational study. They are less reliable than randomized experiments. I know that this is a handful, but I'm going to try to walk you through this because I want you to help you understand why observational studies aren't that great. So imagine a study is intended to determine whether smoking increases the risk of a heart attack. And a group of smokers and a group of non-smokers are observed for several years. And during that time, a higher percentage of the smoking group experiences a heart attack. So I'm just looking on the outside. I haven't put people into a group. I can't say, hey, you smoke. Hey, you don't smoke, right? I'm just observing what's going to go on. But the problem with this is there are other issues to consider. There are other factors beyond just smoking that need to be considered. And so if I'm looking at just the smoking aspect, I don't really know that I can make strong conclusions about the data. So for example, smoking is more prevalent among men than among women. So the smoking group will contain a higher percentage of men than the non-smoking group. And it is known that men have a higher risk of heart attack than women. So the higher rate of heart attack in the smoking group may be due to the fact that there are more men in the smoking group and not to the smoking itself. So observational studies make it very difficult to narrow down to the effects of the treatment or the effects of whatever you're trying to evaluate, just because there are always other factors that need to be considered, other factors that could be playing a role in your specific study. A confounder, so it is a variable that is related to both the treatment and the outcome. So it makes it difficult to determine whether differences in the outcome are due to the treatment or due to the confounder. So that's exactly what we were just talking about. Gender would be our confounder. We don't know if the gender is the reason why that there are more heart attacks, or if it's actually the differences in smoking versus non-smoking, our actual treatment that we're looking at. So it makes it very, very difficult to analyze our data. So just concluding with everything again, you can understand that there are obviously perks to observational studies and perks to experimental studies, and you just have to gauge based on what your treatments are and what your confounders possibly could be, which type of study would be more beneficial in your particular situation.